In C++, a common metaphor is that of a stream. So when I talk about a stream, think about a real stream out in nature. Water flows in a stream, and it can carry things to different places. Things can be added to the stream and removed from it, like this guy catching a fish when it passes him by. Of course, in a program, the things are pieces of data, usually individual characters, and there's a metaphorical stream between the keyboard and the running program. Similarly, there's a stream between the running program and the console window or the monitor. We get this functionality by pound including the IOStream library, and I is for input from the keyboard and O is for output to the console. One source of data coming into a program is the user typing at the keyboard. Cin is used to capture the characters that are in the input stream and store them in variables. Cin works by looking for groups of characters in between white space. Now, a white space character is either a space or a new line. Now, a space obviously is the character you get when you hit the space bar. A new line is the character you get when you hit the enter key, and I usually represent that with a \n. Now, Cin will wait for a group of non-white space characters that is followed by a white space. The Cin will take the collection of characters and convert it into the appropriate type based on what variable we're reading into. Cout is also a stream. We use it to write data out to the console window. Now, data in our programs get converted into characters and then sent to the screen. Here the data, the number 123, gets converted into a group of individual characters, 1, 2, and 3, and they're sent through the stream to the console window. Now all output to the screen is left, right, top to bottom. We can't bounce around the screen and print in any order we'd like because that would violate the stream metaphor. Now there are libraries out there that will allow us to print anywhere on the console, but we can't do that with plain old cout. Sometimes this is a pain to deal with, but the metaphor is simple and good for most intro programming courses. Now Cin and cout do all of these conversions for us. These are not the only streams we can use in a program, however. There are also streams to files. These work in almost exactly the same way as Cin and cout, and this was done on purpose, of course, to make working with a file feel very similar to working with the keyboard and the monitor. All we have to do is tell the program where the files are in the file system, and then there can be a stream created that flows into or out of a running program. On file input, again, we look for groups of characters separated by white space, and the program groups them together and sends the converted data into our program. On file output, our data is converted to characters and written to a file. These are the steps that we need to do in order to use file input or output. We need to include the file stream library, create one or more file stream variables, make an association between the program and the file, verify the association that was made, and then use the file stream variable like it was Cin or cout. To read or write to a file, we would include this code at the top of our program. This allows us to use the library of code designed to work with files. IOStream, again, is the library used for using streams with the keyboard and monitor. FStream is a similar library that allows us to work with files. There are two types of file stream variables, ifstream and ofstream. ifstream variables are for reading data in from a file into our programs. ofstream variables are for writing data out to a file from our programs. In this example, I'll read from a file, so I'll need an input file stream variable. Now this is creating a variable, which I'm calling infile, whose type is ifstream. You can name your variable anything you'd like, but its type must be ifstream. This step opens the file for reading, because this is an ifstream variable and we're reading from a file. The path to the file states where the file is on our file systems. And you can use your File Explorer to find this information, the exact path to the file. This step is like creating a pipe or a stream between the file and your program. Your program can now read in data from the stream. Now before we start attempting to read in data, we should make sure that the file was actually found. Now when you attempt to open the file, one of three things can happen. Either the file path is valid, in which everything is good, And there's a method called good in the file stream library that returns true if this is the case. So most of the time, this is what we're shooting for. We want good to return true. If the file path has a typo in it because you mistyped it, this is bad. The good method will return false if this happens, and your program should handle that somehow. It should either kill the program or prompt for a new file path, throw an exception, or whatever. Another thing that could happen is the file path refers to a file that isn't on your computer. So sometimes we think we know what the file path is, sometimes we do it from memory, but sometimes we're wrong. And if we misspecify the file path, this will also cause good to return false. So we should always wrap our code that's going to work with the file inside an if like this. Now make sure to use forward slashes to separate the parts of your path. Backslashes have special meaning in strings that will cause the program not to find the file. So one of the uses of backslashes, like I mentioned before, is to identify new lines. A new line in a string can be represented with a \n. So don't ever use backslashes when you're representing a path. Always use the forward slashes. Okay, step 5 is to use the file stream variable like it was either cin or cout. In this case, because we're reading from a file, we're going to use it like cin. This will cause groups of characters from the file separated by white space to be brought into the program and stored in variables. And that's exactly what we're shooting for, so that we can get some data from the file into our program. Lastly, writing to a file works very similar to using cout. So instead of creating an ifstream variable, you would create an ofstream variable, the O for output. And one note about opening files, when you do this in your code, it wipes out any file contents that were present in the existing file of the path that you specified. Or, if the file doesn't exist, it creates a brand new file that's totally empty that you can begin to write in. Okay, now you can use outfile just like it was cout. And that's an overview of how to use files in a C++ program.